Next we will see a short expression on coefficient of coupling or coefficient of magnetic coupling. A magnetic coupling means an electromagnet having two limbs wound with the copper coils, and these copper coils are called as primary and secondary windings. These primary and secondary windings having some terminology like L1 L2 is called as primary and secondary inductance, primary and secondary self inductance respectively. N1 N2 is called as primary and secondary turns respectively. I1 and I2 is called as primary and secondary current respectively. M be the mutual induction which is depends upon N1 phi to 1 divided by I1. N1 is the primary turns, phi to 1 is the flux link between secondary to primary winding divided by I1. I1 is the primary current. We can put K1 phi 1 in place of phi to 1. We can put K1 phi 1 in place of phi to 1 because phi to 1 is always depends upon magnetic coupling. I repeat that. We can put K1 phi 1 in place of phi to 1 because flux is always depends upon magnetic coupling. So we can put K1 phi 1 in place of phi to 1. So we get equation 2 phi 2. Similarly, mutual induction between two coils is equal to N2 phi 1 2 divided by I2, means mutual induction between two coils depends upon secondary turns into phi 1 2, flux link between primary to secondary winding divided by I2. I2 is the secondary current. We can put K2 phi 2 in place of phi 1 2 because the flux is always depends upon the magnetic coupling. So we get equation 2 phi 4. Multiplying equation 2 phi 4 and 2 phi 2, we get m square is equal to n1 k1 phi 1 divided by I1 into n2 k2 phi 2 divided by I2, equating the equation. So we get m square is equal to k1 k2 into the first bracket n1 phi 1 upon I1 into the next bracket n2 phi 2 divided by I2. These brackets are self inductance of the primary and secondary winding respectively. So we can put L1 and L2. The L1 and L2 be the primary and secondary winding self inductance. So we get m square is equal to k1 k2 L1 L2. Take a square root of both the sides. M is equal to under root of k1 k2 into the next under root of L1 L2. Let put k is equal to under root of k1 k2. We get m is equal to k into the bracket L1 L2. M is equal to k into the bracket L1 L2. M is the mutual induction which is maximum when k is equal to 1. When put k is equal to 1 into the equation 255, then we get m is equal to under root of L1 L2, means at that time the mutual induction is maximum at that time. When coefficient of coupling is 100% at that time, mutual induction is also maximum at the point k is equal to 1, where k is called as coefficient of coupling. Hence get k is equal to m divided by L1 L2, m divided by under root of L1 L2. Okay, coefficient of coupling is the ratio of mutual induction to the under root of self induction. So when k is unity, at that time mutual induction is maximum at the point k is equal to 1. Okay.